Hey, welcome back. In this video, we're going to be looking at taking limits algebraically without a calculator. And you might remember a lot of these. Now, we're going to solve these a lot different than you probably did last year in pre-cal, mainly for the AP exam. We're trying to get you guys ready for the AP. So let's go ahead and try this. So for question number 3 here, we want to find the limit as x approaches 5. And if we notice, if I plug in 5 in the numerator, 25 minus 25 is 0, and the bottom's also going to give us 0. But the AP does not like that. So instead, this is what we're going to do. We're going to rewrite it. We're going to say the limit as x approaches 5, because I know they both approach 0, of x squared minus 25 is the same as the limit as x approaches 5 of x squared minus 4x minus 5 equals 0. We never want to write 0 over 0. That's a big no-no. The same thing is true for later on, infinity over infinity. Those are no-nos. The reason we do that is because if we say something 0 over 0, it's really what's called an indeterminate. So, and that's really what we say, that this is indeterminate. Indeterminate means we really don't know what it is equal to. So what we can do now we can apply what you did last year in pre-cal. We're going to use that factor and cancel. If I look at the numerator, I'm going to rewrite my limit. I can rewrite the numerator as x plus 5, x minus 5. The denominator would be x minus 5, excuse me, x plus 1. And the x minus 5 will cancel, and now I can plug in the 5 without worrying about it if it will be an issue for us. And this becomes on top 10 over 6. You don't have to reduce it. Let's try number 4. Now, number 4, the top here is 6, the bottom is 4. Notice this is not indeterminate. Indeterminate just means I don't know what it is equal to. I know what this is going to equal. This is just going to be 6 over 4. Looking at number 5 here. Yep, that's going to be 0, and the bottom will be 0. So we are going to rewrite it, the limit as x approaches 2 of x cubed minus 8 is the same as the limit as x approaches 2 of x minus 2, which are both 0. We should say this is indeterminate. We'll talk more about that later on this year when we get to what's called L'Hopital's rule. For right now, I just want you to make sure that you know that word. Factoring it, the top is a difference of cubes. If you forgot it, look it up. This is going to become x minus 2, x squared plus 2x plus 4, and the bottom is just x minus 2. Now, if you notice, you see how we got this 0 over 0 right there? Even though we can't say it, when we write it, we can say it. Notice how that part cancels out. The x minus 2 is what gave us the 0 over 0. So anytime you have 0 over 0, you typically have a common factor that will reduce out. And now plugging in, what we're going to wind up with here is 2 squared is 4, plus 4, plus 4. And again, you don't have to simplify. You can leave it like that or just write it as 12. All right, let's have some fun. Oh no, Trigalicious. I can directly plug this in. This is just a sine of pi over 2, and we should know that that's just 1 right there. So that's just 1. Ideally, the limit equals the value, and because here the limit and the value are the same, we actually have a word for this. It's called continuous, that the limit and the value are exactly the same. All right, let's try this next one here. I can just plug it in. I get the sine of pi over 4, the cosine of pi over 4, which is just root 2 over 2 times root 2 over 2, which is just, what's that, 2 over 4, and if you want to reduce that to 1/2, you can. Cotangent, let's try this one. We get the cotangent of pi over 2, Well, oh no, I don't know what cotangent of pi over 2 is, and that's okay. I know that cotangent is the same as the uh, cosine of pi over 2 over the sine of pi over 2, which is just 0 over 1, which is 0. So, easy. But what if it was a tangent of pi over 2? That would be a d and e. All right, over here, let's see, we can probably, this is just, we can split it. So I can plug this negative 3 in here. It becomes the absolute value of negative 3 plus 1 plus 3 over negative 3. Notice, do I have 0 over 0 or infinity over infinity? Nope. You can leave your answer like this. That's cool. But if you're fancy, this is just 2 plus a negative 1 or just 1. 10's a tough one for us. Okay, 10's a really kind of a tough one for us right here. So let's see this one. When we plug into 3, notice we get the square root of 4 minus 2, which is 0 over 0. So we're going to say our rule because we got that 0 over 0. This is indeterminate. So we're going to say that the limit as x approaches 3 of the square root of x plus 1 minus 2 is the same as the limit as x approaches 3 of x minus 3, which is 0. Now, you might remember, hopefully remember, how to solve this one from last year in pre-cal. We are going to use what's called the conjugate method. And the conjugate method just says take whatever the radical part, multiply top and bottom by the conjugate, like so. The top, going to rewrite that limit as x approaches 3. The top just becomes x plus 1 minus 4, and the bottom becomes x minus 3 times the square root of x plus 1 plus 2. The top and that will cancel. That's my 0 over 0. And what I'm left with, always rewrite the limit. You do not get credit if you forget that limit. And this just becomes 1/4 right here. Whew, that one's pretty bad. That's probably the worst one there is. Until we get to number 11. All right, so for number 11, let's plug this in. Again, if I plug in 0 here, I get 1/3 minus 1/3, which is 0 over 0. Again, this is indeterminate. So you should write out your statement. But we're not going to have much room to write out the statement for this one, so I'm going to be a bad boy and skip that step. But instead, I'm going to show you how to solve it. I'm going to introduce you to your new best friend. It's called the LCD. This is already a complex fraction. And what we're going to do here is we are going to multiply by the common denominator. So if I take a look at all three of these terms, what's the common denominator? The easiest way to get it is to just multiply everything. The 3 plus x, the 3, and there's a 1 down there. So what I'm going to do is my common denominator is this 3 plus x and this 3. And what I'm going to do is I am just going to multiply the top and bottom by that common denominator. This is going to be a skill we will use all year long. It's a very fun skill to do. Makes math much easier. When we distribute, this 3 plus x here cancels. What I'm left with instead, when I distribute here, the 3 plus x will cancel. What we're left with is just the 3 first. Next, I distribute to the second term. The 3's cancel, and I'm left with this minus this 3 plus x. The minus came from here. The bottom, leave it alone. Simplify the numerator. We get the limit as x approaches 0. This just becomes x over x times 3 plus x times 3. X is canceled. Be careful. 1's left on top. And now if we plug in the 0, we get 1/9 right there. So 10 and 11, I will say this. You will see those again. Quiz, test, nightmares. We like those, okay? All right. Next one. Here we go. Number 12. Number 12, this is just a straight plug and chug. If I plug in 0, we get 2 to the 0 plus the sign of 0 is just 1 over 0 squared minus 4. So that becomes 1 plus 1 over negative 4, or 2 over negative 4. I don't simplify, leave that alone. So now let's have some fun with infinities here. Infinity is always a fun thing to work with. Okay, so here's one thing I want to talk about infinity. We never write infinity. Never write infinity. In your problem, okay? Sorry. Let me qualify that. Never write infinity like in your problem. Your answer can be infinity, but you never want to say something like this. You never want to do this. 2 times infinity squared plus 3 times infinity, because these don't really mean anything for us. So we never write that, okay? So instead, we're just going to do it in our head. If I take this is just 2 times x squared. But if I let x go to infinity, this becomes infinity plus infinity. So what's infinity plus infinity? And I'm going to write this in red because remember, I'm doing the red part in my head. In my head, I'm thinking this. What's infinity plus infinity? Well, that's just infinity itself. Now, next one. Because it gets weird, let's take a look at 14. Again, in my head, this is what I'm thinking. Here, if I plug in 2 times infinity squared, that's infinity. But what's 3 times infinity? Infinity. So what's infinity minus infinity? Well, infinity minus infinity, well, I want you to think about that. Should that be 0? Is that 0? No. Not all infinities are the same. Infinity doesn't equal infinity. Remember, infinity doesn't really exist. It's not really a number. So what we need to think is which is growing faster, which matters the most. And if I take a look at this 2x squared, that parabola grows much faster than a line. So if we think of if I let x be like 100, 100 squared is far greater than 300. And as x gets even larger and larger and larger, the difference between those gets even bigger. So even though they both approach infinity right here, even though both of these approach infinity, 2x squared approaches infinity much faster. So this positive infinity, this infinity is always going to be bigger than the second infinity. So what happens here? Well, since this is a positive, whereas this is still going to approach positive infinity. Okay, so we're going to say that this is also going to approach positive infinity. Now, you might be thinking, whoa, that's kind of weird. Well, think of the graph. What type of shape is it? That's a parabola. As x goes to infinity, what happens to the y values? It's also approaching infinity. We just don't want to think of everything graphically. We really want to think about just really what kind of matters most here. And to give another example of that, let's take a look at number 15 right here. For number 15, right, I'm going to think about this. What matters most? Anytime I think about infinity, I always think about what matters the most. As x gets really large, what really matters the most? So I'm approaching infinity. That becomes infinity minus infinity again. I just switch them around. But what happens? Well, if I think about it, there's 3x and there's 2x squared. Well, what matters the most there? Well, obviously the 2x squared, and it's negative. That 3x, as x gets really big, doesn't really matter much. So what I'm looking at, so I don't have to worry about that little infinity part right there, because it doesn't matter as much as the 2x squared, because this is so much bigger. And that's what we're looking at. What matters most? What's going to make it grow the fastest? And what am I left with there? Minus infinity. And that's what we get. We get negative infinity. When we get to solving limits of infinities, we're going to talk a lot more about that as well. All right, this is a funky one. Well, what happens to the cosine of infinity? Well, what happens? Well, if we think about this, cosine looks like this. It wiggles for sure. So what we want to find out is, well, what's happening to it? As x goes to infinity, what happens to this? Well, cosine goes between -1 and 1. Does it ever really approach a number? And of course, the answer is no. It never really approaches anything. So therefore, we say that this oscillates. Oscillates. There we go. So if something oscillates, we just say it does not exist. Therefore, the limit doesn't exist. It's not approaching anything. It's just going back and forth, bouncing back and forth between two ideas. It never approaches anything because that's what a limit does. It has to approach a number. And something that oscillates never really approaches a number. All right. Same thing that happens with tangent. Well, if we think of the tangent graph, it just looks like this. That's what tangent looks like right there. So it's just going back and forth between negative infinity and infinity forever. So same thing, D and E. It's never approaching a number. All right, number 18. Let's see here. So for number 18, notice the top here is 0, the bottom is going to be 0. So I would write out my statement. The limit as x approaches 0 of x to the fourth minus 5x squared equals the limit as x approaches 0 of x squared, which is 0. Remember, this is indeterminate. Therefore, we can rewrite our limit. Factor out the x on top. I get x cubed minus 5x. Whoop, I can factor out an x squared. Sorry. There we go. Fixing that. X squared minus 5 over x squared. Those cancel. Plug in 0. We just get negative 5. Easy peasy. Number 19. Let's take a look here. That's 9 minus 3 minus 6. So the top is 0. And the bottom is 0. Again, indeterminate. So we would take the limit as x approaches negative 3 of the top, x squared plus x minus 9 is the same as the limit as x approaches negative 3 of x squared minus 9 is 0. Now I can factor and cancel. Listen, I agree with you. This is a headache, but we need it. Okay? Need for any credit. Okay? Need for credit. AP is really strict about that. I can factor the top, go ahead and do it. X plus 3, x minus 2, x plus 3 on the bottom, x minus 3. Again, remember, I got that 0, 0. That's what cancels out here. Those x plus 3s have to cancel. So kind of, if you know you have indeterminate, boom, there's one of your factors. X can't be negative 3. So you can kind of say, oh, look, x plus 3 has to be one of my factors. I get that straight from my limit. Big brain. This becomes minus 5 over negative 6, whatever that is. I'll very simplify. All right. Hope you guys enjoyed this video. We're going to take a look at some more limits in just a few moments in my next one. Hope to see you there. Bye-bye.